All right. It is 3 minutes after the hour. We're going to go ahead and get started. So, welcome everybody. Thank you for being here. Hope everybody's having a great holiday season. Welcome to our December 2025 installment of ENERCALC Office Hours. If you're a regular, you know the drill. If you're new here this month, we have just a couple of quick things to check off our list before we get going. And one of those housekeeping items is just our quick sound check and tech checks. So if you direct your attention to the bottom menu of the Zoom window, either in your browser or in your desktop app, you'll see that we have a chat tool. We also have the reaction emoji capabilities. If you're able to hear me right now, just go ahead and give us a thumbs up or an okay in the chat, throw us a reaction, what have you, so that we know our audio is coming in loud and clear. That's perfect. Thank you so much. And before we get going on the rest of our introductions and start today's program, we also want to do a sound check and visual check for our primary speaker for today's program. So Mac is going to go ahead and share his screen. And then once again, here in just a moment, if you can hear Mac's voice and see his screen, again, go ahead and give us a thumbs up or an okay. So go ahead, Mac.
Hello, everyone, and welcome to Office Hours.
All right, looks like you're loud and clear, Mac. Now that we have our tech checks out of the way, we're going to go ahead and disable the chat capability and move on to our introductions. We are going to have Q&A open throughout the session today. So my name is Seth Roseworm. I'm a senior structural engineer and a software developer here at ENERCALC. Our presenter for the monthly ENERCALC Office program is Mac Elterhony. Mac is a senior structural engineer here at ENERCALC, and he pretty much splits his time between technical training for ENERCALC customers, working with the ENERCALC engineering team on the actual specs and engineering behavior of our software, and then helping maintain a presence for ENERCALC at national and regional events throughout the structural engineering industry. Mac is also a founder and managing principal of Elta Design Group, which is a specialty structural engineering firm. And he's been an ENERCALC user for about a decade, so he has a lot of great insight about the needs of our customers. If you're new here this month and you're not sure what Office Hours is all about, this is just a way for us to have simple, direct lines of communication between us and our users. And there's several avenues through which we do that. We showcase new features, let you guys know what's the latest, greatest, what are the newest updates in ENERCALC. We show optimized design workflows where we walk through specific modules. And then we do live Q&A through our hands-on examples. Each session as well. So if there's ever a question that's too involved or it's going to require deeper digging, that might be a better fit for the support team. If there's investigation involved, to look under the hood and get answers to your questions. As a minor point of order, you will notice everybody's microphones are muted just so we don't get any echo or feedback during Mac's presentation today. As always, we do have an open Q&A at the end of every session. If you want to submit a question for that, just use the Q&A dialog in the lower dashboard of your window. If you experience audio problems at any point during the session, you can simply refresh your browser or jump out and rejoin the session. And if you ever want to rewatch today's program or share it with someone on your team, all these recordings for ENERCALC Office Hours are posted to our Office Hours page on enercalc.com as well as our ENERCALC YouTube channel. And with that, I'm going to go ahead and hand it over to Mac to get going on our program for today.
All right. Again, hello, everyone, and thank you, Seth, for the great introduction as always. And welcome to another great session of our monthly Office Hours program. As Seth said, I am Mac Elterhony, and I'm excited to be presenting to you today the would-be module from ENERCALC's library of diverse and extensive modules. So I'd like to start our session with a brief overview of the overall agenda. Today we will be covering a PDH announcement, and then we'll go over ENERCALC's latest build, what's new in ENERCALC, and then we'll really dive into the would-be module, and then we'll talk a little bit about how to register for office hours so you're notified in the future directly in your email. And finally, we will wrap up with live Q&A. So please feel free to drop your questions in the Q&A form throughout the presentation. So beginning back in May, we started offering 0.5 PDH. So this is not new anymore. It's been a few months. So we offer these PDHs to our live attendees to represent the guaranteed technical portion of the presentation. The name, and this is the important part here, is that the name that we use in the certificate is the name that you used today to enter the Zoom session. So please make sure you put your name the way you want it to be displayed in the certificate. And in a few days, you will get an email with a link to download that certificate. So I'd like to encourage everyone to always update to the latest build. We issue updates monthly to ENERCALC, and we fix all kinds of things from minor bugs to graphical issues to enhancements. So please make sure that you take advantage of the latest and greatest. Um, so if you take a look at your inner calc that you have in your computer, and if this number right here is not saying 20, 25, 11, 24, then you are behind. So we do these monthly updates. We release them monthly, and we want to make sure that you're taking advantage of these new features or new program capabilities. Um, and to do this is a very simple process. You click on this update button on the top right corner of the software of your upper ribbon menu here. You click on update, and that will take you to this window. You can check for updates and launch the for our users page to download the latest build. So if you just click on this button right here, and that will take you directly to our website. You will find a couple of links here. This is for those who don't have ENERCALC at all installed on their computer. And for your case, for my case, for everyone's case here who has ENERCALC, then they just want to click to download the Build 20 updater. This expects to see ENERCALC, files and ENERCALC program on your computer, and it's just updating the elements that got updated. Or that we're updating. So if you click on that, and you'll be able to download that to your desktop or to your download folders, and then you can just run it, and you will be good to go. And if you would like the program to automatically check for updates at program startup, you can again go to that same menu, and you just make sure that this option is checked. And I'm still repeating this now a year later. I'm still repeating this part right here because we do still get people who are stuck in this twilight zone. So if your inner calc is stuck in between these two bills, 2023 830 to 2024 228. If you are stuck in there, then you will need to do a one-time manual update. This is because the feature that notifies you of the availability of new updates to the software, that feature just doesn't work for some reason. So and it doesn't function properly. So if you're in this group here, the group that's affected, then you'll need to just follow the same process that we just talked about. You click on this button, you do that manual update one time, and then after that you can have the software then you'll be good to go, and it will notify you of every time that there is a new build. And again, the current build is 2025 11 20 11/24. So moving on here, if you prefer to be notified of the latest and greatest, updates from ENERCALC, if you want that by email, you can scan this QR code, or you can just go to enercalc.com slash update dash emails, and you just sign up your name here, and that will make sure that you get these updates directly to your inbox. So if you have not been aware of what's going on in the world of ENERCALC, what's recent, what's new, all the new functions, I want to just briefly take you through some of these changes that have been taking place over the past few months. The first item is decoupling everything, and this just happened, I believe, 2 months ago, in the 2 months ago update. So pretty much, if you click on this building code and load combinations button right here, you will see a whole new menu or a whole new layout, I guess. And the user now has the option to mix and match everything. meaning that you can use whatever IBC you want with whatever version or edition of the ASCE 7, whatever edition you want, from the NDS. You can mix and match whatever you want to make a set of calculations work to your liking. So in this example right here, you see that we're using the IBC 2018 with ASCE 722 and the NDS 2024. So clearly they're not matched. But if that's what your jurisdiction requires, then now you have the ability to have your calculations run precisely the way you want them to run, and of course the reports will show these design standards. So this way, your calculations are in compliance with the with your jurisdiction that you're working in. However, if the user doesn't want to mix and match, then the user doesn't really have to know which edition of the ASCE matches the IBC 2018, or which edition of the NDS is referenced in the IBC 2018. You don't have to memorize that or know or look it up on your own or any of this. So all you'd have to do really is just click on this button right here. This button says Sync Reference Design Standards with selected IBC edition. So whatever IBC edition you select here or you have chosen here, then you can click on this button, and then it will bring all of these in line with what the IBC 2018 is referencing. So if you click on it, that's exactly what happens. And you can see just at a glance, if you look at this, you'll find that the concrete masonry, they're in black, while the other ones are in this kind of orange yellowish color. And the orange yellowish color indicates that the design standard is different from the default standard that that this particular IBC references. This means that at a glance, at least, it tells you that this one is not referenced in 2018 in IBC 2018. This one is not, this one is not, and this one is not referenced in IBC 2018. But as soon as you click on this button, everything here comes to compliance, and it turns into the defaults that the IBC 2018 references. So once you have this kind of all done, then you're good to go. Everything is compliant with the IBC version that you selected, as you can see here, ASCE 716 instead of 722. So keep in mind, all of the code changes that we just did will only apply to the calculations within this ENERCALC file. This means if you want to apply the code selection as a default for all future projects, every time you open a new project, it will show the default as the selection that you just selected, then you will need to take it a step further by clicking on this button. This means that whatever you're showing, and if you click on this that says select or set default governing code and design standards for all new project files, then what happens that if you click on it, you will get this window, and it will show you the old defaults, and it shows you the new default that you want to change it to. For example, the old default was IBC 2018 and ASCE 722. That's the old default. But if you remember here, when we synced everything, now this becomes ASCE 716, and that's exactly what happened here. So I'm trying to just set these as the new defaults. If I look at them, if they look great, if everything looks fine, then I click save and close. If they don't look right, then I cancel, and then I make the adjustments that I need to make. So once the new defaults have been selected, then every time you open a brand new project folder, brand new ENERCALC file, then you will be able to use these, or those will be the default values for the code and the design reference standards. So next thing we have here is the new tab, and I say new, but it's definitely been a few months now. These new tabs right now that house the ASCE 722 loads and forces modules. And we have a tab here for seismic, a tab for wind, and a tab for other loads. A user can create a calculation for whichever one they want, and they can create as many as they want. Previously, the user can only create one calculation per loads and forces module. But now you can, have as many as you'd like. So it is important to note that these tabs will only show up if and will only show up and have these um, modules in them only if you have selected ASCE 722 as your design for your design loads, if you have used that as your reference standard. If you use something else, then ENERCALC will revert back to the old way of handling business, which is really the old options with the menu to select the loads and force module the way that we used to do that. We used to do it. So what I'm trying to emphasize here is that if your design loads is ASC 722, then you can create your wind loads, your snow loads, and all of that directly from these tabs. However, if you switch to ASCE 716 or ASCE 710, these guys right here will show up again because that would be the older editions of the ASCE, so they're right. They will be populated right here. But if you have ASC 722, they will show up here and they will disappear from the main menu. So they'll disappear from this side. And this is very important to know because I think a lot of people don't realize that. And then whenever they start working and they realize that these disappeared, it it definitely is a cause of cause for panic. And we want to make sure that this is exactly the reason why it's happening. If you change your ASCE, you will be good to go. Next is native load linking within ENERCALC, and this has been such an exciting feature that we've had for a while now. And for those who don't know it, load linking is an ENERCALC native feature that gives you the ability to automatically link reactions from one calculation to another. So the ability to change something pretty much in one member and have the effects of that change practically trickle down to all of the supporting members downstream. Load linking is currently available for steel beams, wood beams, steel columns, and wood columns, and we are actively working on integrating more modules as we go. So if you'd like to learn more about load linking, I created a playlist of short videos on YouTube to walk you through how to use load linking step by step, so you can start leveraging this tool in your projects. I also added a new video recently, about 3 months ago, I believe, or so. That a new video here to the YouTube load linking playlist for a full practical example of how to use load linking in real life design application to transfer reactions from a wood beam to a steel column or from a wood beam to another wood beam and so forth. So we've got a pretty decent variety right here to show you how steel and wood, the load linking for steel and wood is interchangeable and they all play together nicely. This definitely is a huge help to minimize the risk of transcription errors. But in reality, the most amount of help I get out of this is whenever you have, rafters sitting on a beam, sitting on a column, or maybe a beam, then a transfer girder of sorts. If you have just this spider web of members sitting on top of each other, it's definitely nice to be able to have this automatic method of tracking the loads and bringing them all the way down without you having to do this manually and transcribe them from one calculation to another and track all those changes. Another update is the ability to export tabular detailed results from ENERCALC to a CSV file. This is, of course, useful to many engineers who like to post-process the results outside of ENERCALC. Maybe they have their own calculators or spreadsheets or something that they want just to take some of these values that we provide and they want to post-process them. So this makes it a little bit easier to interface with other tools that your team might have at their disposal. And for example, you can click on whatever detailed results you want. For example, the ASD shares a moment, and I can just right click, save to a CSV file, and they'll be downloaded will be good to go. And you can export results pretty much to CSV for pretty much all of our modules now, columns, beams, slender walls, shear walls, foundations, and all of our analysis modules. This is also something that we added in recent months by popular demand for quite some time now. But we made an important update to the general footing module. Our users now have the option to specify top reinforcement in the footing for those cases where you have tension at the top of the footing rather than your typical case of tension at the bottom. You pretty much can specify rebar size and quantity separately for each direction. You can see it right here. So the standard module that we've had for the longest time, it used to have just bottom reinforcement, and of course parallel to X and parallel to Z. So those are the two directions, and you can have the bar size and the quantity of rebar controlled differently for each section. Now you can check this option to say specify top reinforcement, and you can do the exact same thing. So this allows you to specify the four reinforcement that you need to have, the four layers. And we expanded here our results to try to be a little bit more descriptive. So it says, bottom tension, bottom, top tension, top tension. So it just kind of helps you a little bit in each direction and and what controls in that direction to give you a little bit of more ease of navigation. And another item that's been really a huge help to many people is ENERCALC for Revit, especially for firms that already have the engineers do their own modeling. They do a lot of the work in Revit. They do, and they use ENERCALC to perform a lot of their designs, beams, columns, and all of that. ENERCALC for Revit is pretty much a Revit plugin that allows you to design structural members fully within Revit without having to export information or analytical models or analytical sticks or anything to another outside calculation software. You can do everything directly from your familiar Revit environment. So it's a simple point and click, as you can see here, and you just click on the member and you follow the guided prompts that you'd get. And once you answer a few questions, you'll be good to go. And before you know it, you'll be done designing that member. And the best thing about it is that it automatically carries those reactions for you. So if you designed a beam, it knows that, okay, this is the beam you have, this is the reactions you have. And next time when you go and you design the column next to that beam or adjacent to the beam, it will say, okay, well, you have this beam framing into that column. Do you want to grab, this is the reaction that's coming from there, and it'll grab it for you, envelopes it, and it takes care of it, and it tracks this load path very intuitively and very, very easily. And of course, you have great highlights here, so it always shows you if the beam is designed, then it's green. If it's failing, it's red, and all of those great visuals to make your life easier, especially if you're reviewing someone else's work. And currently, we support, or ENERCALC for Revit supports steel beams, steel composite beams, wood beams, steel columns, foundations. And this is, biaxial loading. As far as foundations go, they take loads in all directions. Steel column take load, biaxial loading. So you get the full capabilities of ENERCALC modules baked into this. So you'll have a full gravity load path. So with the other item here I want to highlight is that with every new update to ENERCALC, we send out release notes to outline what changed, what got updated, what got fixed. So if you want to sign up for that, it's pretty simple. Again, from the same update menu, you just click on subscribe to new build email updates, and pretty much you will get an email every month whenever we issue an update. It says, okay, well, these are the things that we fixed, and you can kind of glance on them quickly and see if there's anything that that interests you or that's something that you've been waiting for. Moving on to the focus of our session today, and that is the wood beam module. we use this module to design, wood rafters, wood beams, and all year really wood beam members. And this is something that um, I don't think that I know anyone who uses ENERCALC and doesn't use this module, or honestly doesn't. I don't know anyone who doesn't get a lot of use out of this module. It's very popular, so it's a good module to use to go over and end the year strong. So here's a quick overview of the capabilities and the features of this module. It, of course, performs full design checks based on the selected NDS edition to determine the section capacity. You can apply various types of loads, such as uniformly distributed load, partially distributed load, concentrated loads, and trapezoidal loads, and all that. ENERCALC provides the user a great level of flexibility with load combinations, and some of these things, honestly, this applies to a lot of our design modules. Designs dimensional lumber as well as engineered woods. Another example today is going to be based on engineered woods type of product. The next item, of course, is link reactions from different calculations for easy and accurate load application. We'll see this in action today. And last but not least, of course, a summary PDF report for calculation for your calculation package to be submitted to the jurisdiction or for your own firm's records. So we're going to keep this simple today. And the objective of today's session is to walk you through um, how to use the wood beam module to design an LVL wood beam that supports roof rafters spaced at 24-inch on center. Very simple. This is going to be based on IBC 2018, and the LVL span is going to be 14 feet. The wood rafters are again 2 by 10, and they are at 24 inches on center. And in addition to the regular roof loads that we have, we want to support an additional point load of 300 pounds, and we're just going to consider that as dead load. And we're going to put that load is located at 5 feet from the left end or the left support. This is exactly what we're trying to do. So with that, we need to follow the same familiar process that we need to follow to start any ENERCALC calculation. So we start by clicking on the Add button right here, and then we navigate in these tabs. So we're going to follow here this Beams tab, and then we click on the wood beam module to start a new wood beam calculation. The ideas are always the same with ENERCALC. You start from the left-hand side and you work your way to the right, and until you just finish all the tabs, and that's when you know that you're done. So we'll give our calculation a name, and we're just going to call it wood beam because that's what we're designing. So we're not designing the rafter, we're designing the beam. And I do personally all of my wood design in ASD. So if so that's what I'm gonna use for this example. But if you are an LRFD design guy, then that's an option that ENERCALC allows you to do. So you can just click on this option right here, and ENERCALC will incorporate all the proper LRFD factors. So you can for your stress designs and all that. So but for us, we're just going to go ahead and use the ASD design methodology. And now let's get to the fun part. So we need to pick the material. So you can manually input the various values for the material you want to use manually right here. So you can just fill this up. Or you can pick the material you want directly from the database. So what we're going to do, of course, we're going to just select on the database button right here. When you select on the database button, you get this window. So you will get multiple options right here, and you need to choose the option that you want. So for example, if you're working with if you're trying to do two buys, for example, then this is the table that you want. If you want to do glulam, then that's where you add here, and so forth. For us, because we want an LVL, so this is going to be an engineered wood product, and that's what we're gonna go for. So from there, we'll get a list of engineered wood manufacturers. Once you click on this menu changes obviously based on the option you chose. We chose this, so we get a bunch of manufacturers right here. And the one that we're interested in is the eye-level truss joist, and in particular, the Microlam LVL, and we're using the 1.9 E product. They do have a 2.0 for the modular for bending, but we're just the one we're using here that's more common here is 1.9, but you can also use the 2. You can use whatever you want, but that's the one that we're going for. So once you find the product that you want, then you can click on select, and you'll be good to go. It'll automatically populate the information for you. Now, if the product that you want is not already pre-listed in ENERCALC, the user has the option to click on this user defined right here. So if you click on user defined option, and then you can do insert, and you'll be able to create your own material. Of course, you need to know the various design values, such as your FB and your shear, your FV. You need to know your FC, your modulus elasticity for your e-bending, e-minimum. You have to know all of that information. But you can create whatever material you want, and once you input all these required values, you will be able to use the material that you specified, and ENERCALC will run the proper NDS code checks for you based on the values that you input. So if you ever have an engineered wood product, for example, that isn't already pre-listed, like here, then you can always just create your own and be able to run your numbers that way. So in my case, again, I'll be using just the Microlam LVLs 1.9E, which is, of course, pre-listed in ENERCALC. So I'll just select that and move forward. And again, you'll see that all of these values have been auto-populated for us, so we don't have to do anything manually. It's worth noting here that you do have an option for how the shear is calculated. So the user has this option to calculate the shear at the support, and that's what the default is. And if you check this option, or if you want to implement this option, then it will calculate the shear at a distance D, which is really the depth of the member, at a distance D from the support as allowed by the NDS. This helps you to sharpen your pencil a little bit. I will not be using this option, but in case you want to, you can. Just keep in mind how this is implemented. So, for example, if you have a beam that is in a bearing condition that just sits on top of, let's say, a column, then that, or a post, that beam, for ENERCALC to know what that D distance is, D is really just the depth, but it's gonna just, count it from this point. But if it's bearing, you might have, we don't know, or ENERCALC doesn't know what that width of bearing is. So you gotta be aware of what just happened there, because if you have a width of bearing that's 6 inches and your D is 9 inches, well, it's not gonna know that, oh, the first 3 inches, half of that bearing width is just the bearing width, and D is really from the face of the support. So that's something that ENERCALC wouldn't know. So you just be careful how to implement this option. Either way, for me, I'm just not going to implement it. So I'm not going to be worried about it. But if you do use it, just be aware of how it's used. Also, if you do have within that D distance, if you do have point loads, the code does not allow you to ignore them. So if you're allowed only to ignore the distributed load or the uniform distributed load portion, but if it's a point load within that D distance, you can't ignore it from shear perspective. So that's why if you use this option, just be aware of the various nuances in there. If you skip it and not use it, then it'll just use the full shear and everyone's happy. So moving on here, the last item that we have under this tab is the bracing for the compression side of that member. And this is, for lateral bracing for lateral torsional buckling, or really the beam stability factor calculation. So this is a roof beam with wood sheathing on top of it. So I am comfortable assuming that the compression side of the beam is fully braced. However, you can pick other bracing conditions. That's what matters, that you do have the options to do whatever you want to do. So you can pick other bracing conditions, such as bracing at certain spacing intervals, maybe every 2 feet, every 8 feet, every 5 feet, whatever you want to do. You can say it's completely unbraced. Also, if you have a multi-span beam, so this is a single span, just the 14 feet, but if you have a multi-span beam, you can define the bracing condition for the beam as a whole for just all of the spans of the beam, or you can pick one span at a time and you say, well, for span number one, we're fully braced. For span number two, I'm not braced at all, or maybe I'm braced only at 2 points or whatever. So you have a great level of flexibility in determining what that bracing look like. So then again, for us, we're just going to go ahead and assume that's compression sides fully braced. Moving on to the next tab, which is the beam span data. So we have, again, one span. It's right here, and it's 14 feet based on our example. And now we're ready to determine a size or use a size. So we have one of two approaches here. The first approach is to just pick a size. The first approach is just like, okay, well, I think this is the size that I want to use. I think this would work, or maybe this is, you have an idea that you want to test. So you know a particular size, 1.75 by 11.87. That's what I want to use. So I'll just click on the micro lamp. So this is right here, and then I'll get the various sizes that are recorded under the TJ micro lamp, the LVLs. So then I'm just using this size. I can go there, click on that, and see if this one works, or if it doesn't work, then I'll change it, I'll play with it. And this is the manual method. So that's the first approach. Another way of approaching this is using the auto select button right here, this button right here. So the auto select button, this second option right here, allows ENERCALC to auto select sizes for you by clicking, on this button and then getting this window and choosing certain parameters. So if you click on the button right here and you get this window, you will be able to almost kind of choose. First of all, you can choose your wood type, what do you want to use. So it's a micro lamp, so it looks into that family of members. And then you can start narrowing down the sizes by saying, okay, well, I'm okay with the maximum stress ratio all the way up to 1, or 100%. Or maybe you'll say, no, I don't want anything more than 0.9, 90% or 85 or whatever. So you can put what is your maximum stress ratio here. You can put your own deflection, total load deflection, and transient load deflection ratios that you want to not exceed, or your minimums. And then you can say, okay, well, I'm going to set a minimum width limit, and I'm going to set a maximum width limit. I'm going to set a minimum depth limit and a maximum depth limit. And I can say, no, I don't want multiplies. So I don't want 2 by 10 or something like that. I just want this to be just a single member, and that's all. So you go through the various restrictions that you have, and then you click on Start Design. Once you do that, you'll get this window right here, and it goes through the various sizes, and it will report the ones that match your criteria. So right now it says the 1.75 by 11.87, 1.75 by 14, and by 16. So all these sizes work. Right now they are listed or sorted by weight, so the lightest to heaviest. That's why the 1.75 by 11.87 is on top. But you can sort them by whatever you want. You can sort them by depth. You can sort them by deflection ratio. You can sort them by shear ratio or bending ratio. So this kind of gives you a good idea about the various sizes. And then you kind of have to select which one you want to use. But at least this narrows it down based on your criteria. And it runs this little bit of grunt work for you. So for us, we're just going to go ahead and use this 1.75 by 11.87. So yeah, so it's worth noting that uh, there's something about here that's worth noting that member width and depth are auto-populated based on the member size that's selected. So you selected, 1.75 by 11.87. Those are the right sizes right here, width and depth. They're auto-populated. However, if you do have some sort of a custom size member, maybe you have something that's 2.25 by 14 and 3/8. If this is what you got, if you got the manufacturer to make something like this for you due to maybe special conditions or whatever, you can always put that information here and it will run the numbers based on that because it uses these sizes or these numbers right here, the width and depth, to come up with your IX and IY, and of course your area and all of the other information that you might need to move forward. So if you have something different, you can always use that right here. Now, this option, we're not going to get into it that much because it's not part of our example, but this option that says all spans minor axis, YY bending, this one right here means that this member that you're using, the 1.75 by 11.87, if we want to load it in the minor axis on the weak axis, aka flat Ys, if that's what we want to do, then you click on this option right here, and it will run the numbers based on this member being flipped on sideways and run in the weak axis. And always, if you're ever in doubt, if you click on the 2D or the 3D, you will be able to see an actual accurate depiction of the member. So if it is loaded in the minor axis and you click on the 2D diagram or the 2D sketch or the 3D model that the ENERCALC produces, they will have the member shown in the proper orientation that matches your selection. So for us, again, just to get back to what we're doing here, this member is just going to be loaded normally in its strong axis. So the width is 1.75 and the member depth is 11.87. Moving on to this bottom portion right here, ENERCALC calculates and auto-select many of the ASD factors, such as the stability factor or the duration factor as well. So ENERCALC will do a lot of this work in the background. And again, the stability factor, there's a calculation to that, and it does the calculation in the background, and it will like tell it'll put that number there for you. However, there are certain factors that still require user input. So, for example, the wet use factor. So for bending and for shear and for your modular elasticity here, the wet use factor could be different for all of these. So you do have the option to input whatever you want. So for this example is going to be 1. You can see here we have the use CR, the repetitive member. This is a beam. These are not rafters, so there's just a single beam. So you don't have to, or can't use the repetitive member factor. We can't get that extra increase in capacity. So this option, we're not going to choose that. But if this was a repetitive member, ENERCALC honestly has no way of knowing this. So you'd have to tell it that. It can't just automatically know it on its own. Same thing here with the temperature factor and the flat use factor. Also, or so we're using one for all these. And then this one right here, the apply incising factors. The incising factors you need to calculate them. There's a little bit of logic they have the ENERCALC follows to come up with what that number is. But if your member is not really pressure treated or anything, then there's really no incising there, so you don't need that factor. For our member, it's not pressure treated, so I don't need it. But if it was, then you would click on this option if you're designing a member that's pressure treated to make sure that this works, or that the incising factors are being applied properly. So the next tab here is the span loads. And if you remember, in our example, we have 2 sources of load. Source number 1 is the point load of 300 pounds, 5 feet, from the left support. That is the first source of load. So for us to do that, we just click on the add button, and then you click on a concentrated load. And I like to put a description or write a description here where that load is coming from. So I'm writing here as additional point load. You can kind of write whatever you want if you have RTUs or if you have any weird conditions. I'm just putting here the source load is additional point load, and I'm putting 0.3 kips, which is 300 pounds, and it is 5 feet from the left-hand side. The other source of the load is really the roof loads. You know, you have your roof live and you have your roof dead, and that load is applied. And normally, many times, if you were doing this project in a vacuum or you're designing this beam in a vacuum just by itself, you would just go and click on a uniformly distributed load. You will put 20 PSF for dead or whatever that you have, and then roof live, you put that. If you have any vertical wind, you put that. You do what you need to do, snow, of course, and then you will pick the option that says, maybe you want to add the tributary width. So you'll pick that and you say, okay, well, this has a tributary, width of 5 feet or 8 feet or whatever. So this way it calculates your area loads for, you give it the area loads and it calculates your line loads on top of your beam. That's the manual process. And if anything changes there, you'd have to come back. If that tributary changes from 5 feet to 8 feet, you'd have to come back manually, do this work on your own. However, and there's nothing wrong with the traditional way. That's what we've been doing for years. But what I want to do today is I want to take you to the next tab. So, which is this right here, this new shiny tab that we have, the linked loads tab. So what I did for me to design this building, we had to design those wood rafters anyways, the wood rafters that sit or, that frame into the wood beam. So I actually right here before, we're designing the wood beam, but before that, I designed the wood rafter right here. So this has been designed. We know what, we're using 2x10s, I believe, or something like that, 2x10s, 2 feet on center. Everyone is happy. And what I'm trying to do here, I'm trying to link the reaction from that wood rafter directly to the wood beam. So if anything changes, I will just change it right here in the wood rafter, and then that change, the new reactions will trickle down and they will automatically be updated to the members downstream. So to do this, once you click on the linked loads tab right here, the first thing you see on the left-hand side is a list of all of your other calculations that you can grab reactions from. The calculations will be listed right here, like, wood beam, maybe there's another beam number 2, beam number 3, whatever it is that you have. So we have wood rafters. So if you click on the wood rafter, this 2D diagram actually changes, this 2D sketch changes to reflect the actual condition, to reflect the actual calculation that you selected. So for us here, we're clicking on the wood rafter. That's the only option we have now, but if we had others, they would have been listed here. So if you click on wood rafter, you will get this 2D sketch, and it gives you a little bit of, quick hints like, oh, this is 12.5 feet. That's for the span. It's a 2x10, and you have this much dead load and this much live load on it. And if you can see right here, this is telling you to select a reaction below. So that means, is this end is the end that frames into your beam, or is it this end that frames into your beam? So this is end number 1, that's support number 1, and that's support number 2. This is uniformly loaded members, so 1 and 2 are the same, but if they weren't, if we have extra point loads here or whatever, and then, we just need to know which one is framing into the beam that we're currently designing. So with that said, I'm going to say that, what I'm interested in is this support reaction 1, or the reaction from support 1. So I click on that. Once you click on it, the next step is to determine how that load is applied or how that reaction is applied. This button right here that says specify, this assumes that this reaction is applied at a one specific point, 3 feet from the left, 7 feet from the left, whatever it is. It's applied at one specific location. You put it right there. This second option says midspan. Again, it's a single application of the load at the middle of the beam. This right here is a third point. So that means two application points, one at the 1/3 point, and the other one is at the 2/3 point. This one is the quarter point, so that's three application. But none of these work for us because we have a rafter at 2 feet on center. So that means we are in this category. It's called spacing. So it asks you, where does it start from? I'm saying from zero. And it's repeated you can put here your spacing every 2 feet. So once you do that, then you can click on the add button. In my case here, it's update because I already have the load included. So when you click on it, you can just update it or revise it. But if you're applying the load for the first time, you'll be able to say link load. But it's the same button essentially. So once you do this and you apply that load, then you can see at the bottom a summary table of all of the already linked reactions. And you can see it right here. It says it comes from the wood rafter. It comes from support one, quantity is one. That means, how much it's applied or what the reaction is not amplified. It's just that one reaction and it's applied at spacing and it's applied at the full span right here. And it also shows you how much of it is dead load and how much of it is roof life, because when it brings it, it doesn't just bring one enveloped reaction, but it brings the full load set. So this way it gets included in the load combinations for this beam. So once that reaction is linked, it will show up in this table and everyone is happy. And of course you can here delete or unlink, or you can, do a little bit of manipulation here too, if you have, if you made a mistake and you want to, or maybe if you want to copy a second set of reactions and all that. So once that's done, you can see that all of the loads have been applied, and it shows right here in this 2D diagram, all of these loads have been applied and you're good to go. And of course, lastly, here is your load combinations. You have combinations for strength combinations, you have combinations for deflection and reaction combinations, and you can do whatever you want to do there, turn them off, turn them on, add new ones, and so forth. Now that you're really finished with all this, now you can finally evaluate the results. So if you click on calculations and summary results, you can see your maximum bending stress ratio right here, your maximum shear, your deflection ratios, and your extreme reactions per support. You get, of course, all of your shear and moment diagrams right here. And this is your 3D model that I was telling you about that you have in ENERCALC. Everything in blue means that this load is linked. What's shown in red, that means that this load is manually applied. So again, at a quick glance, you can see if your load is linked or applied manually. So if you want to make any changes to it, you can easily do that. So this kind of wraps up the wood beam module. And what I want to show you, another thing that I want to share with you today is that I want to note the growing library of verification calculations that we've been creating recently. So you can navigate to them by just clicking on for our users page, documentation, and then verification calculations. And you'll see a list, a small list, but we're adding to it. And you can see, for example, this is the wood beam verification calculation that I did. So you can see here, it takes you through the whole process, and then it shows you or attaches an ENERCALC report for that same, calculation. So this way you can see your the hand calculation versus the reported results. This gives you a good idea of what's happening within ENERCALC, and also it's a great learning resource for, of course, younger engineers, and it's a quick refresh for those who need it. And as always, you can go to our enercalc.com/office hours to see what's new with our office hours, to find all of the previous recording, and to sign up and register to be notified for the next session. This year has been great, where we attended multiple national local conferences and connected with our users. 2026 is shaping up to be another great year with plenty of conference appearances lined up. So keep an eye out for when ENERCALC comes to a conference near you. So come and say hi to us if you see any of these familiar faces. And I think that's the end of our presentation today. I want to remind everyone that in the next few days you'll receive an email that has a link to your certificate. And we're ready for live Q&A.
All right. Thanks, Mac. Let's get into some Q&A here. So first question, are there any plans to include plywood beams per APA supplement 523 in the wood beam module or create an additional module for it? So I can tell you that I'm not aware of any active projects in progress on this topic. Um, like Mac was going over today, our wood beam module is focused on primary standard NDS sections that he went over. However, if that's something you're interested in, you can always send that as a feature request. That's how things make it on the leaderboard, so to speak, for development team effort is from customers reaching out and tracking the frequency and number of requests that we get on that. So feel free to reach out. Question from Ronald. I've been having issues with loading ENERCALC. It appears a few other DLLs can no longer be found. Okay, if you're getting a missing DLL warning on starting up ENERCALC, we recommend doing a clean install, just running the full installer from enercalc.com. Go through that process, and then if you're still having trouble, don't hesitate to reach out to the support team, support@enercalc.com, to get some help on that, because you shouldn't be getting any warnings like that. And we'll be happy to dig into that for you. Next question. Mac, I know you're familiar with this one. Is there a way to check a beam in an uplift loading combination where the bottom of the beam is not continually braced, but the top is, bottom flange bracing not matching the top flange?
Yeah.
So I know Mac has thoughts on this. I have thoughts on this. It's a known limitation. It's on our radar. We definitely have the intention of not leaving that limitation permanently in ENERCALC. But Mac, if you want to address some workarounds, obviously there's the dual calculation approach and so on.
Right. Yeah, yeah. Unfortunately, yeah, it's we're working on it, and the thing is that at this point, yeah, you'd have to at least that's what I do is to run a duplicate calculation for the uplift. Especially if I'm worried about uplift controlling, or you can provide extra bracing, because at the end of the day, your uplift load is not going to be as high most of the time as your gravity load downward. So you might be able to get away with just a little bit of extra space, extra bracing, and avoid a duplicate calculation if you're confident enough or if you're comfortable enough. But on the other hand, yeah, you'd have to run a separate calc for the uplift case.
And I will just add, you want to absolutely make sure that you're not manually creating that duplicate calculation from scratch. You should definitely be
Absolutely.
taking advantage of either the copy or clone capabilities from inside your original calculation to go and
Yeah,
make that
right here.
alternate calculation. Yep. Yep. So clone
Right.
is from inside the calculation when the calculation is active. Or
Right.
if you're out on the main project manager window, you can use the copy command, which will also create a perfect duplicate of your calculation. And that's even true if you happened to be doing this process in ENERCALC for Revit, you're working in a calculation that was sent using Revit geometry to ENERCALC, you can still copy or duplicate that calculation from your project manager view to get a separate what if scenario for it. Question from Lutfi. My 3D tab does not work. I'm going to assume you're talking about the Woodbeam 3D tab. You'll want to make sure that you're on the latest update, which is 2025 1124. And if you are on that latest update and you have valid input data, then just go ahead and reach out to the support team, include your details of your build number and your calculation file. You will notice in some cases, especially in steel beam, you don't have a 3D view or a 2D sketch if you don't have a valid section size specified. So that's the first thing to check. But yeah, don't hesitate to reach out to the support team if you have valid inputs on the latest build and you're still seeing. Once in a great while, there are certain hardware configurations or graphics processors that don't like to play nice with those 3D schematics. So don't hesitate to reach out to the support team about that. All right, Mac, question about linked loads. When linking those rafter loads, can a rafter be specified at x equals 0 and X equals L related to
Yes.
load racking to columns.
Yes. So if I understand correctly, what you're trying to do, you're trying to apply that same reaction at two different locations, and you can absolutely do that. So I'm just gonna delete this, or I'm gonna update this to say specify and for the beam, and I'm gonna put this at 0. And you can see it right here. It's just this blue one right here. And I'm gonna grab that same reaction again, and I'm gonna apply it at 3 feet, for example. So it's that same reaction, reaction number one, apply it again, and now it's shown up there. And if I want to do the same thing, I'll grab the same dude, and I'm going to apply it at 8 feet, for example, put it right there. So you don't have to have a uniform spacing. You can apply that same exact reaction multiple times at different weird intervals based on what your project needs.
Yeah, absolutely. One of the things we love most about load linking is that it's not a one-to-one relationship. You can relate a particular reaction to many different calculations, many different locations on another calculation, and so on. Feel free to ask if you have follow-up questions on that. Question from Steve. On the printouts, how do you keep the loads from doubling up on each other? So we definitely know there's some things we want to see cleaned up on our 2D visualizations for loads, which of course crosses over to your printed report. If you have a densely loaded point load situation or a number of linear loads right on top of each other, you can sometimes get some schematic overlap. Feel free to reach out to the support team if you have some screenshots of a specific condition that you're struggling with, but please rest assured that is on our radar and we don't intend for the kind of messy overlap situations to persist in those 2D visualizations. This one ties in closely. Mac, can you provide suggestions for wood members subject to wind uplift? Although it's a slight twist on that, we seem to receive unusual results, especially with beams that have an overhang. If you're seeing numerical results that don't match your expectations, please go ahead and reach out to support@enercalc.com. We want to see what that condition is right away, replicate that condition, and get into whatever calculation outputs you have going on there. So please reach out with that. If you're asking generically about wind uplift related to the bracing condition, we already touched on that. But if you have other calculation concerns, go ahead and reach out to us with that. We'll want to hear about it. We'll probably need some additional detail on this question. I have a question regarding seismic force applied to a beam. Thank you. Feel free to ask if you have more, but as Max showed us in the loads, both in the span loads, loads all spans, and linked loads, seismic is definitely one of the categories that you can apply. We do have seismic in all our load combinations, and even obviously for vertical effects, then the ability to set your SDS values or your omega values. So feel free to dig in if there's more you want to ask there, but you absolutely can, in all ENERCALC modules, use all of those basic 7 load cases that come from the code. Are you able to plot the verification calcs for all member designs or just specific example of what is happening behind the scenes? Mac, do you want to tackle this one? It sounds like they're asking generically, hey, can I do verification for my calc, or is it just for that standard calculation you documented?
No, it would be just for the standard calculation we documented. It's not an interactive thing because that's what ENERCALC is for. But this one is just for the calculations that we did, or that one example that we did.
Yeah, exactly. All right. Next question. Any plans to add TJI joists? So this is probably something you want to go ahead and reach out to the support team with a feature request. Obviously, as Mac indicated, we do have LVL engineered sections as well as glulam support for proprietary engineered type sections. TJI is not something ENERCALC does right now. A lot of times that's done by manufacturers, Warehouser, and that kind of thing. But if that's something that there's interest in, feel free to reach out and ask that.
Yeah, I also see Mike here is very interested in TGIs. I saw his comment here.
All right. Next question. For space loads on linked reactions, is there a way to say when the space loads stop? So a start and a stop location. So in the interface that Mac was showing,
Uh-huh.
it's basically
Gotcha.
a perpetual regular spacing from the
Yeah.
start location to the end location. So there's a from and every, there's not an end location. The end would be either the span or the end of the beam based on how you've got it set up.
Yes, if you're trying to end it at the end of a span, so if this is a multi-span member and you want to just have it repeating at 2 feet until it finishes with span one, but you don't want it in span two, yes. But if you want it to be applied almost like a partially applied load, maybe from zero, if this beam is 14 feet, from 0 to 8, I want you to apply it at 2 feet on center. Within that one span, there isn't a an automated way to do that. Does that make sense what I was trying to say here?
Yeah,
So
exactly. And
yeah,
like we discussed in the answer to the earlier question, you always have the ability to go ahead and link a particular reaction multiple times at
yeah.
different locations. And so because it's not a one-to-one relationship, you can take that reaction and link it at a number of arbitrary locations, a few extra steps, but you do have that flexibility and it's all dynamically linked. So if you have an update in the future, then those values will update. All right. Next question. Um, if we're checking a slab as a strip in ENERCALC concrete beam module, how can we avoid the shear stirrups requirement as per the code applied? Any information regarding this issue? Yeah, so obviously we're aware that some engineers who are designing one-way concrete slabs do use the concrete beam module to assist with that process. Um, and we have some FAQs about this as well as um, in the documentation specifically for the beam module. You can use the beam module as an aid, but you're going to have to use some engineering judgment. You can extract some valuable information, for example, your moments, the analysis, the flexural design. You may have to take some of the detailing requirements with a grain of salt because it's specifically geared toward beams. So we don't have a purpose-built slab module at this time. Mac, do you have any thoughts to add on that?
No, that's it. Yeah, you covered that, right?
All right. Is there a way to input different beam sections on a continuous beam on several spans, including concrete beam? So Mac has the interface up right now for wood beam. Wood beam does not provide the capability, as far as I can remember, to provide a different section from span to span. The steel beam module does, obviously, because when it comes to steel beams, you can actually provide continuity through welding, and you could have continuity from one section size to another as you go from span to span. The concrete beam module, I believe, also does allow the capability to use a different section size, span by span. Um, and steel composite, obviously, we're only doing simple span because steel composite doesn't support moment reversals. So hopefully that answers your question. What is the main difference between wood beam design and multiple simple beam design? This is an interesting one. So multiple simple beam is sort of a convenience feature that some customers really, really love, which is why it still exists, but it's not functionally um, engineering wise any different than simply building a series of individual calculations using the individual material specific modules. So for those who aren't familiar, Mac is showing the multiple simple beam module on screen right now. And what it basically does is just let you create a series of beam calculations inside one calculation instance in your project instead of having a multitude of individual wood beam or steel beam calculations. Functionally, it's a little bit more limited because as you can see at the top of Mac's screen, we've got a simple span and you can just add left cantilever, right cantilever. You don't have those multi-span capabilities. So that's probably the biggest functional difference that you would see. is that you can do robust arbitrary span geometries in your wood beam module. You can also do load linking in your wood beam module. Those capabilities are not available in your more simplified interface of multiple simple beam. Go ahead, Mac, if you were going to draw attention to something.
No, yeah, that's exactly what this is for. I personally, when I use the multiple simple beam module, is if I have, for example, a single story building and I'm just running a bunch of, beams or rafters, wood rafters, and one is like 10 feet and one is 12 and one is 13. And I want to just document every one of these, but I don't want my project manager to be just completely crowded with 20 calculations. So that would be a fantastic place to put a lot of these simple span or maybe just a single beam with a little overhang on one side. Housed all, I think we can house up to 10, if I remember correctly. You can put up to 10 in here in under one, one under one hood, I guess, one calculation. So that's where this really shines. It doesn't crowd your ENERCALC and at the same time you run the various conditions, and you might not want to print all of these conditions, but this is kind of your um, quick verification that okay, well the 11-foot span works and the 12-foot works and the 9-foot works, and we're good to go.
Cool. Quick comment from Mike that TJIs would be awesome. Mike, absolutely. If you haven't already,
Yeah.
feel free to send that to the support team if that's a feature you're interested in. It's almost like voting. The more feature requests the engineering team accumulates for a certain feature, that's how we direct effort towards it. So don't be a stranger. Reach out if that's stuff you're interested in. Um, Mac, a question on the verification calculations. Can you show us again where to actually navigate to see those
Yes.
verification hand calcs?
I actually was exactly going to do that. So if you go
Perfect.
to just enercalc.com and if you click for our users and you go to documentations, you'll see right here. You'll find, the user manual, some training videos, but this is the one that I'm interested in right now is verification calculations. You click on that, it'll take you to this page right here. And currently we have a few of these, but most notably, we got the steel beam, the wood beam, we got steel column right here. So you can see those are, in my opinion, are easy to follow calculations. They tell you exactly which version of the code this is or which edition of the code this is based on or design standards. And it walks you through, this is for steel column, it walks you through where the references are, what we're doing, and it takes you through the full step by step, almost like textbook style calculation where you get to see everything. And then you see the following ENERCALC printed report for that same member that we designed by hand. You can see right here and you can compare. So for example, bending stress ratio right here is 0.734. And if you go to our calculations way up here, there you go, 0.735. So you can kind of compare what you have in the calc versus what in the calc is reporting. So this is for steel columns. We have steel beam. This is a full worked out example of a rigid diaphragm analysis with
Oh, so pretty.
yeah, I know. This one is was great. So this walks you through the whole thing. If you feel like you're really into it, that's where it's at. And you can again, you can compare this directly to the results reported here by Intercalc. But at least this gives the users an idea of what logic lays behind all of the results that they're seeing. And this is the one here that I'm highlighting now. This is for the wood beam. So you can go this is actually the rafter that I was talking about that I designed. So this is a 2x10, 24 inch in the center. And you can see this is all of the stuff, the analysis, the design checks, all of the various codes here, various information or code checks. And again, it relates, and as it relates to intercalc directly, intercalc printed calculations. And we'll be adding more of these as we go. So
Absolutely.
stay tuned.
And just to again clarify, as that earlier question touched on, these are static verification examples that show generically, basically demonstrate the internal calculations happening inside ENERCALC. These are not hand calculation style report printouts that you can generate for your individual calculations. So this is just a set example verification that you can access on our website. All right, next question. Are there any plans to create a module for wood diaphragm design and or deflection? So hopefully you guys don't get too tired of hearing this, but if there's ever something you have a question about that doesn't exist in ENERCALC, absolutely send that to us. Um, I don't know if you guys have ever visited the About Us page that actually shows the ENERCALC team on our website, but we're real people. And even though we serve a huge number of customers throughout the United States, we're a very small team, and we're all practicing engineers who come from industry, and a team of software developers who have been working on this product a long time. And so we want to do what customers want and need. And our whole engineering team looks at those feature requests when they come in. And those are things that we consider carefully because we all came from engineering practice to work with ENERCALC. And that means a lot to us to see what customers want ENERCALC software to be. So, you know, people may occasionally get tired of hearing like send a feature request, but we really look at those and we really consider them carefully. So stay in touch when there's those things that you guys want to ask about. So, for example, your wood diaphragm design, diaphragm capacity, deflection, absolutely send that over as a feature request because it helps us form a better idea of what practicing engineers need and want ENERCALC to be. Is there a workaround for the design of tapered and or notched wood beams? Mac, feel free if you want to share thoughts on this. There's not explicitly any capabilities for that in the existing module today.
No, yeah, I agree. Yeah, there really isn't. Uh, yeah, I don't think I can't think of a good workaround, to be honest.
Yeah. Okay. Uh, Again, that would be a great feature request for future consideration for the wood beam module.
I mean, yeah,
Question
like
from.
unless you
Oh,
want to
sorry.
be
Go
like
ahead.
super, sorry, yeah, unless you want to be super conservative, and if you're a notch, then you kind of either assume that you lost the whole capacity, or maybe if it's at shear, if it's notched towards the ends, I think you can do another set of calculation that can do the shear calculation for you. But if it's
Yeah,
notched
that was
throughout
going
the
to
thing,
be
it becomes an
that was going to be
engineering.
my comment was if you have a duplicate calculation, you could substitute a shallower section um, to evaluate shear capacity. But obviously, that has other downsides. Um, Question from Razim. I just connected. Can you answer my question about pressure treated lumber? So, good question. Mac touched on
Yes.
all your different factors, the NDS factors for beam design. One of those is the incising factor. Incising factor refers to the effects from the process of basically penetrating the wood beam to inject the pressure treating material, and that can be set right here where Mac is showing.
Right here. So if you apply the incising factor, the incising factor is like there's a calculation that takes place in the background. So if you say you apply it, then the calculation will occur. It'll calculate the factor, and then it'll multiply it by your stresses as required by the NDS to reduce those capacities.
And then obviously on top of that, don't forget your wet use factor if you're going to be in a permanently saturated
Yes,
environment.
that's right. Right there.
Next question. I would suggest that ENERCALC add a module to design concrete pile cap. this is a this is an interesting frequent flyer topic that Mac, what session was it where we talked a lot about pile caps and we got down the rabbit hole a little bit with
Yeah,
strut and
two
tie
sessions
modeling
ago.
and yeah, so we had an interesting discussion earlier this year where some questions were posed about pile cap design. Oh, it was because we did the group pile analysis. Um,
Yeah,
a lot of you may know ENERCALC has the pile group analysis module, which basically takes an applied loading and transfers that loading to axial force demands in the individual piles within a group. That gave rise to some interesting discussion about design of pile caps. And we talked about a number of different things, including the CRSI handbook approach to pile design, um, deep beam analogies with finite element modeling, strut and tie modeling either by hand or by finite element. I've done all of those different processes in design practice. And I know there's engineers in here today who have done those as well. There's not a single consensus solution about the best way to design reinforced concrete pile caps because it's either a very complicated deep beam problem or a 3D strut and tie problem. But if that's something that customers are interested in, absolutely hesitate to, or don't hesitate to let us know about that, and we'll go ahead and keep an eye on it. It's difficult to tackle things like that where it's very experiential and engineering judgmental because we don't want to put ourselves in a position of making engineering judgments on your behalf as a design professional, which is difficult when there's not a closed form solution. And pile cap is definitely one of those scenarios where there's not a single consensus closed form solution. Great question, though. It's a very interesting topic. Comment from Mike, you could use FE for tapered beams. Um, and next question, are there any plans to add capability for retaining walls with 2 rows of piers? Good question. The current cantilever retaining wall module does let you use piers, but it's a single row with a specified eccentricity from wall center line to pier center line. That would also be a great feature request if that's something that your team does a lot. Oh, and I have to just a quick callback to our earlier discussion about differentiating beam cross sections from span to span. The steel beam module is the only module right now that lets you have a different section from span to span. Shout out to Chelsea for fact checking me on that. Concrete beam module does not allow you to specify a different section. You can do different reinforcing from span to span, but not different gross section geometry. There was a question from Husick about seismic loads. Please reach out to the support team, and we'll be happy to tackle whatever your question was in more detail about beam seismic loads. Well, that was a lot of great questions. I think
Ah,
we're probably ready to wrap up here. Mac, do you want to kind of close us out with a look at next month?
yes, absolutely. Well, I want to thank everyone for your time today. We really appreciate you being here. And next month, office hour session will be held on January 14th. We will be covering the steel beam module. Thank you and have a great end of year. And I will see you on January 14th.
All right. Well, once again, we thank everybody for being here. Thank you guys so much for your time. We always look forward to these sessions. And from the ENERCALC team to all of you guys, we want to wish you guys a very Merry Christmas, Happy Holiday Season. Enjoy the rest of it, and Happy New Year. And we will see you guys at our next session. Everybody have a good one, and thanks very much.